So, if it's asking us to sketch the rotation angle and state the reference angle, then for this first example, 243 is going to be in between 270 and 180. There's my rotation angle. And if I go to the closest x-axis, then there's my reference angle. And I'm looking for the distance between that 243 degrees and the nearest x-axis, which would be at 180 degrees. And the distance between 180 and 243 is going to be 63 degrees. When I go to my next example, at 337 degrees, it's going to end in quadrant 4 here. There's my rotation angle of 337 degrees. Here's my reference angle. And the reference angle is going to exist between 337 degrees and 360 degrees. And the distance between 337 and 360 is 23 degrees. When I get to my last one, where it's at 70 degrees, I draw out my rotation angle. And we find that when it ends in quadrant 1 like this, the nearest x-axis is actually just rotating back to 0. So this is one of the unique cases where my angle is 70 degrees for my rotation angle, and my reference angle is also 70 degrees. Now, because we have 4 quadrants, we have 4 positions where we could have the same reference angle. If it's asking for a reference angle of 58 degrees, then I could have that occur in quadrant 1. I could have that occur in quadrant 2. I could have that occur in quadrant 3. Or I could have that occur in quadrant 4. When it says state the measure of the rotation angle in each quadrant, the easiest one will always be in quadrant 1. And the reason for that is that in quadrant 1, my rotation angle is equal to my reference angle. So in quadrant 1 here, it'd be 58 degrees. In quadrant 2, we can see here that it's rotating all the way over here. And if I combined my rotation angle with my reference angle, it would make 180 degrees. So I can always solve for what the other one is by saying if I have my rotation angle, it would be 180 degrees minus my reference angle. Or in this case, 180 minus 58 is going to be at 122 degrees. When I get to quadrant 3, my rotation angle, in this case, is going to be rotating all the way past 180 degrees. So it's going to do that full 180 and then rotate an extra 58 degrees. So I can say that it would be 180 degrees plus my reference angle, or 180 plus 58 is going to be at 238 degrees. And last but not least, when I do quadrant 4, I'm going to rotate all the way around, but I'm going to come up a little bit shy of that 360 degrees, exactly my reference angle shy. So my rotation angle would be that full 360 degree rotation minus my reference angle of 58 degrees, or 302 degrees. If it says let point of 5 and 8 be a point on the terminal arm of the rotation in quadrant 1, state the coordinates of Q, R, and S, which are on the terminal arms of the rotation in quadrant 2, 3, and 4, respectively. Well, I know that if I have the point of 5 and 8 on this arm, if I drew that as a right angle triangle, then that would be the same over here. Except for all that happens in quadrant 2 is my x became negative. I can rotate it downwards, keep the same right angle triangle, still 58 degrees, and my y would become negative. Or I could reflect it in the x and the y, keep the same angle, and they would both be negative. So we can see that if we're keeping the same reference angle, we keep the same points. All that changes is whether x and y are negative. So we can say that we can have point Q at negative 5 and 8. We can have points R in the third quadrant where it's negative 5 and negative 8. And we can have the point of S in the fourth quadrant of 5 and negative 8. Which means that based on the reference angle and what quadrant it is, I can solve for the rotation angle. I can say that if I'm in quadrant 2 and I have a reference angle of 25 degrees, then there's my reference angle, there's my rotation angle, and the rotation angle is going to be in quadrant 2, 180 minus 25, or it's going to give me 155 degrees. If I'm in quadrant 4, and it's 60 degrees from my reference angle, then my rotation angle is going to be 60 degrees shy of being a full circle, or 360 minus 60, or 300 degrees. If I'm in quadrant 3 and the reference angle is 8 degrees, then my rotation angle is going to be 8 degrees more than that straight line, or 180, 188 degrees. The easiest possibility, as we already know, if I'm in quadrant 1 and it's 39 degrees, then in quadrant 1, it's identical. It's just going to be a rotation angle of also 39 degrees. If it exists between two quadrants, then that means that it has to be a multiple of 90. If it exists between quadrants 3 and 4, then that's a fancy way of saying that it could either be 90 degrees to this side, or it could be 90 degrees to this side. And you could calculate that as either 90 degrees more than a straight line, or 180, or 90 degrees less than a full circle, 360. Either way, it gives you the same answer. It's at 270 degrees. The other way that this can be phrased is I could give you a rotation angle, like 256, and I want to know what other rotation angles between, in this case, 0 and 360, but I could put any parameters I want there, that has the same reference angle. So the first thing I'm going to do is I'm going to draw a sketch of what this looks like. I'm going to solve for what that rotation angle is. So it would be going back to the 180. My rotation angle is going to be 256 minus 180, or 76 degrees. And then I can solve for all the missing quadrants. I already know what it is in quadrant 3. So I'm going to solve for quadrant 1. Where it's going to be the exact same as the reference angle. In quadrant 2, it would be 180 minus the reference angle. And in quadrant 4, it's going to be 360 minus the reference angle. And there are the three other angles between 0 and 360 that are going to have the exact same reference angle.